So as we finish our lesson, I just want to review one thing when we're using the standard normal table. We have this last one that we didn't get to, but just to review, remember when you're finding or when you're using a standard normal table and z is a negative value, you want to look for the probability of the absolute value of z. Okay, so a 0.28, all right, it's going to be right here. But because it's negative, remember the idea is this. We have this bell curve, a positive 0.28 is going to be above the mean, all right? And if this area, the 0.6103, gives us this whole area, what we wanted was to be a 0.28 below the mean, okay? So the area that we actually wanted will correspond to the complement of the area that we have here with the 0.6103. So if we subtract 1 minus 0.6103, that will give us the probability below, because this equals this. Okay? So 1 minus 0.6103 will be 0.3897. All right. Okay. So that's the area of this region below. And I mentioned this before, but I would recommend making yourself a little sketch for every one of these. It doesn't have to be anything fancy, but just making yourself a sketch to make sure that your answer makes sense, okay? Because let's say you forgot the complement idea, you put 6103, and then you're thinking, wait, the mean's here, and that's 50%. We're not even up to 50%, so we shouldn't be at 61%, that's for sure. That can help you catch little mistakes. Now, as far as the IB is concerned, you are not going to have to use a standard normal table, okay? But I wanted to show it to you because it is used in a lot of applications. If you well, are any of you juniors? None of, oh yeah, I thought we had, okay. If you go on to take like AP Stats next year, they only use this, they use a standard normal table a lot, okay? If you guys take any kind of statistics in college, which actually is a very common course to have in a lot of different majors. For example, when I was in school, I was a math major, so I didn't have to take that class, but all the education majors, even like social studies education, they had to take a basic statistics class. Business majors had to take a statistics class. Pre-med majors had to take a statistics class, all right? So this is used a lot in those. So that's why I wanted you to get some exposure to a table like this as well. For us, the nice thing is we can use our calculators. And this is a function that you've used before, but notice the difference here. Because we're dealing with a standard normal distribution, the mean will always be 0. The standard deviation is always 1. Because remember, we're talking about, sorry, not x, but the z-scores are distributed normally with a mean of 0 and a variance of 1 squared. Okay? So that's why we're always using 0 and 1. For all of these, because we want a lower bound, these are going to be the upper bound, okay, for all of them. And you can work through those. All right, I think we've done enough practice with the calculator that we don't need to do all of those. But what this does do is this will give us a more precise solution than what we were able to get with the table. Because as you can see here, for one thing, the table only goes to the 100th place for the z-score. It also makes it easier when we have these negatives. Okay, we don't have to think in terms of a complement anymore. We can just plug it in and it'll do it for us. Okay. Now, let's look at a couple of applications that aren't just here. Find the z-score for this. Find the z-score for this. And these are the kinds of things that you will see on the IB exams quite a bit. Okay, things like this. Suppose we know the standard deviation is 8, and we have a score of 50, and a score of 50 has a z-score of 1.3. We can use that to find the mean. Okay. What's our formula for z?
Z equals x minus the mean over the standard deviation.
Good. All right, z is x minus mu over the standard deviation. So we can plug in what we know. We know the standard deviation is 8. We know the score, or x, is 50. So 50 minus, we're solving for the mean. And we know that that's going to equal 1.3. So we can work our way through the algebra. It's basic algebra once we have it set up. Okay. So we multiply by 1.3. We're going to subtract that from 50. Okay. 1.3 times 8 is 10.4. Yeah, 10.4. So 50 minus 10.4 is going to be 39.6. Okay? So that would be our mean. You guys know how to do the algebra. Once we know that, then, we're able to figure out some other things. What score has a z of negative 1.5? Okay, now that we know the mean, we know the standard deviation. Let's think about this. If we want to be 1.5 standard deviations below the mean, that score is just going to be the mean minus 1.5 times the standard deviation. Okay? So we have 39.6 minus 1.5 times 8, which that's 12. So 39.6 minus 12 is 27.6. Okay? Any questions so far? Try this one. Similar question. What score has a z equal to 2.3? $58?
Yeah, that's what I got.
You had what? Did you do minus? Or because this one, notice z is positive here. Okay?
you do the z-score times the standard deviation plus the mean, and then that'll give you the
Yeah, whatever the z is. This was minus because we wanted a minus 1.5. Okay, so good. We have our mean 39.6 plus 2.3 times 8. Okay. 2.3 times 8 would be 18.4. Is that right? 18.4. So 39.6 plus 18.4 is 58. Okay? All right. So there are a few different things that we can do with that. Let me show you one other application here. And we'll see how we could get this kind of data. Actually, in our next example. Okay. Well, yeah, let's do this first. Let's say that we have two scores. Okay? Let's say that we know, and this is the kind of thing that you could get from like the percentile. If you knew you were in this certain percentile, you could figure out a z-score. That's what we're going to be doing on Monday. If you know what percent it is, you figure out what the score is. Okay? But let's say, for example, that we knew that a score of 30 had a z-score of, let's say, 1.2. And let's say a score of 20 had a z-score of minus 0.3. Okay? That actually would be enough information for us to figure out both the mean and the standard deviation. And in fact, if I remember correctly, it was either on last year's IB exam or the year before. They had a problem almost exactly like this. Okay, obviously the numbers are different, but how do you think we could solve this though?
To find two variables, you just need two equations. So you would write both out with the equation for z with respect to the standard deviation of the mean, and you'd solve for one of those variables, plug it into the other, solve for the second, plug it into the first.
Okay. So if we have two unknowns, the mean and the standard deviation, we have to have two equations. Okay? So our formula for z is, I know we've used it a few times, so let's say it again.
X minus mu over sigma.
Good. X minus mu over sigma. All right? That is in your formula booklet, but that's one that you ought to just know. Okay? You're going to use it enough. Okay? So 1.2 is 30 minus mu over sigma. And negative 0.3 is 20 minus mu over sigma. Okay. There's a system of equations, and we can solve it now. Okay? Now, I think what I'll do to solve this, just a little bit of technique here with solving systems. I know this is something you've done in the past, but I'm going to multiply both of these by sigma over, on both sides. So we have a 1.2 sigma equals 30 minus mu. And here I'm going to have a minus 0.3 sigma equals 20 minus mu. And what I'm going to do is I'm going to multiply this second equation by a negative 1. Okay, so that'll be positive, that'll be negative, and that'll be positive. And now notice the mu's will cancel out. So I have 1.5 sigma equals 10. And now we can divide sigma equals 10 over 1.5 or 100 over 15, which gives us 6 2/3. Okay? So now we know sigma is 6 2/3. And we can go back to either one of these, any one of these equations, plug in the 6 2/3, and figure out what the mean is. Okay? So let's say we plugged it into this 1.2 sigma. So 1.2 times 6 2/3 is going to equal 30 minus mu. Okay? So mu is going to be 30 minus whatever 1.2 times 6 2/3 is. And what does that end up giving us? Come on, we have calculators sitting right in front of us. Let's go. Come on.
22.
Does it come out to 22 2/3? 22
I got just 22. You're multiplying 1.2
times 6 2/3.
Yeah, so it comes out even.
What did you guys get?
That whole thing is 8.
Did you get it to work out? What did you get? Oh. What? 22 even? Okay. All right, so mu would then be 22. So here's a case where if we knew percentiles and we apply what we're going to learn on Monday to figure out these z-scores, then we can translate that. We know the actual score, we know the z-score, and we can translate that to figure out what the mean and standard deviation of that whole population must have been. Okay? Now, the one last thing, that what I was mentioning about using a score or using a percentage to figure out what a z-score is, I'm going to just kind of preview here using the standard normal table. Okay, we'll look at using the calculator on Monday, but just as a little preview here, it says, suppose you know that there's a 20% chance of having a score below 30 and the mean of the data is 42, what's the standard deviation? Okay? So let's think about this. Here is our normal curve. The mean is 42. And we know that this value 30 right here has an area of 0.2 below it. Okay? The probability is 20% of having a score below that. Okay? Now, just from the picture, what do we know about the z? And the reason why I'm talking about Z here is because we know the mean, we know the score, we want the standard deviation. The only equation really that puts all those together is Z equals X minus mu over sigma. Okay? What do we know about Z just by looking at this picture? What do you think, Vicky? What? If this is to the left of the mean, Z is going to be negative, okay? If we're to the left of the mean, Z is going to be negative. Here, Z equals 0, right? That's our mean. So to the left would be in the negatives. And actually, if we look at our formula, what we know so far, X minus mu is 30 minus 42, okay? So we know that Z is going to equal a negative 12 over sigma, okay? And you're saying, okay, well, how does that help us? Well, watch this. This is where the 20% comes in. We know Z is going to be negative. So to find out what it is, using our standard normal table, we have to think in terms of a complement. All right, so instead of looking for the 20%, because we're not going to find it, we should look for 80%, okay? So the probability of that X is below the absolute value of Z, okay, is going to be 80%. And if we look here at our table, we have 0.7995. That's the closest to 80% that we've got. So 0.84 is Z. Okay? 0.84. Now again, Monday we'll see a calculator function that'll allow us to figure this out a little more precisely for exactly 0.8. Okay, but when you're using a table like this, you'll just get as close as you can to 0.8. All right, so now we can plug that in and we can figure out what sigma is. Okay, so 0.84 equals a negative 12 over sigma. So sigma is negative 12 over 0.84 if we do the algebra. And what does that come out to? What did you say? Negative 14.28, you said? 29? Okay, good. And guess what? It makes sense that it's bigger than 12, because look, 30 is 12 below the mean, and it's only at 0.84. All right? So a z-score of negative 1, it makes sense, would be even lower than 30. Okay? So good. So we can use different data to help us find a standard deviation for a whole set. Okay? All right, we'll get into that more on Monday. For the practice that I want you guys to work on, these first two actually give us that kind of comparison that we were looking at, if you recall, back when we looked at the triathlon. Remember, here we did 12 hours, here we did 14 hours, okay? But even though this time was greater, we performed better because our z-score was less, okay? Now, whether you want a high score or a low z-score is up to the situation. Here it's a race, so we wanted a lower z-score, right? For numbers 1 and 2 here, they're both talking about mid-year exams or final exams. So for exams, we want our scores to be high, okay? A negative z-score would not be good in this situation. So here they have you finding a z-score for each of these different subjects, and by that, comparing them to the class, we can determine, hey, which was her best subject, which was her worst subject, okay? Here, you know, she got a 48 in English, but hey, the class average was only a 40. So she still did pretty well, you know, as opposed to, and like here, she got an 84 in geography and an 84 in math, but the means were different and the standard deviations were different. So it's not really clear which she actually performed better on. We're going to look at the z-scores to kind of rank those from best to worst performance, okay? Then she has this, or we have these problems here, okay? I know we did a 68, 95, 99.5, just so that when you check your answers in the back of the book, they match up. Use the percentages to the precision they give here, okay? We used a little bit more general there, okay? But you can try some of those, and then there's a couple other ones as well to practice with, okay? All right, so that is it for that.